Hello, good morning students. So now in this session we are discussing the concept of Fourier series. So first we have to know what is Fourier series. So Fourier series is an infinite series expansion of periodic function in terms of trigonometric functions sine and cosine terms. That means we can expand any function f of x as a Fourier series. Okay. So what is period? First, before going to know about Fourier series, first you have to know what is periodic function. So any function f of x is said to be periodic if f of x plus t is equal to f of x, or f of x plus 2t is equal to f of x, or if f of x plus 3t equal to f of x, then t is said to be periodic function. So we know the period of sin x. What is period of sin x is 2 pi. Why it is 2 pi means f of x equal to sin x means f of x plus 2 pi. Sin of 2 pi plus x gives sin x. So the period of sin x is cos x. Similarly, the period of cos x is also 2 pi. The tan x period is pi. So now discuss Fourier series. The Fourier series of f of x. Suppose if f of x is any periodic function, then the Fourier series expansion of f of x can be written as f of x is equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos n x plus b n sin x, where a naught, a n, b n are called Fourier coefficients of f of x or Euler's formulae. So these are the Dirichlet's conditions. No need. So now we'll discuss how to find the Fourier series in the interval 0, 2l. Suppose that means the period is 2l here. So the Fourier series expansion of f of x in the interval 0, 2l is given by f of x is equal to a naught by 2 sigma n equal to 1 to infinity a n cos n pi x by l b n sin n pi x by l. So where a naught is 1 by l integral 0 to 2l f of x dx, a n is 1 by l 0 to 2l f of x into cos n pi x by l, b n is 1 by l 0 to 2l f of x into sin n pi x by l. Suppose you want to find the Fourier series in the interval 0, 2 pi. That means the Fourier series for the function, periodic function with the period 2 pi. So suppose interval 2 pi is given, so we just replace l by pi. So we get Fourier series a naught by 2 n equal to 1 to infinity a n cos n pi x by pi cancel n x. Similarly b n sin n x. So what is a naught? 1 by pi integral 0 to 2 pi f of x dx. A n is 1 by pi 0 to 2 pi f of x into cos n x dx. B n is 1 by pi 0 to 2 pi f of x into sin n x dx. Similarly, the Fourier series expansion of f of x in the interval minus l to l is given by f of x equal to a naught by 2 sigma n equal to 1 to infinity a n cos n pi x by l b n sin n pi x by l. So what is a naught value? 1 by l minus l to l f of x dx. A n is 1 by l minus l to l f of x into cos n pi x by l dx. B n is 1 by l minus l to l f of x into sin n pi x by l. Suppose if the Fourier series in the given interval minus pi comma pi means we just replace l by pi. Suppose if the given interval is minus l to l, we can verify whether the given function is even or odd. See, for example, we know how to know the even or odd function. How can we verify whether the even or odd means? Suppose if f of minus x equal to minus f of x, then f of x is said to be odd function. Suppose if f of minus x is just f of x, then the function f of x is said to be even function. So we know the x square is a even function, x cube is odd function. We know sin x is a odd function, cos x is even function. Since f of minus x, that means sin of minus theta is minus sin theta, that is odd function. Cos of minus theta is just cos theta, so cos theta is said to be even function. So if f of x is an even function in the interval minus l to l, then the function f of x can be written as a naught by 2 n equal to 1 to infinity a n cos n pi x by l, where a naught is 2 by l 0 to l f of x dx. How it is 2 by l means, so we know the Fourier series in the interval minus l to l as 1 by l minus l to l f of x dx. Since f of x is even, we can write minus l to l f of x dx as 2 into 0 to l f of x dx. Since f of x is even, we know cos n x is even function. The product of two even functions is even. So minus l to l becomes 2 into 0 to l f of x cos n pi x by dl. So we know f of x is even, sin n x is odd function. The product of even and odd function is odd function. But we know minus l to l f of x dx is 0 if f of x is odd function. So b n values become 0. Similarly, the Fourier series for odd function is f of x equal to n equal to 1 to infinity b n sin n pi x by l. So here a naught and a n values become 0. Since a naught is 1 by l minus l to l f of x dx, since f of x is odd function, minus l to l f of x dx is 0. So f of x is odd function, cos x is even function, the product of odd and even function is odd. So minus l to l f of x dx is 0. Since f of x is odd function, sin n x is odd function, the product of two odd functions is even function. So minus l to l can becomes 2 by l 0 to l f of x into sin n pi x by l dx. So this is f of x equal to if f of x is an odd function, then the Fourier series in the interval minus L to just f of x equal to sigma n equal to 1 to infinity bn sin n pi x by L, where bn is 2 by L, 0 to L, f of x and sin n pi x by L. Similarly, we have the half range cosine series and the half range sine series in the interval 0 comma L. The half range cosine series is same as the Fourier series for odd function, even function in the interval minus L to L. Same formulas. So half range series means this is also Fourier series for odd function defined in the interval minus L to L. Same formula, f of x is n equal to 1 to infinity bn sin n pi x by L, bn is 2 by L, 0 to L, f of x into sin n pi x by L. So we have some formulas. So all of you go through this formula. Sin n pi we know 0, sin 2 n pi 0, cos n pi minus 1 whole power n, cos 2 n pi is 1. So stop this way. Continue. So obtain the, now we'll discuss problems related to the Fourier series. Obtain the Fourier series for f of x equal to e power minus x in the interval 0 to 2 pi. So the given interval is 0 to 2 pi. That means we have general formula c to c plus 2l. So lower limit is c, that is c0. So we have c plus 2l is 2 pi. That means l is 2l is equal to 2 pi, l is equal to pi. So what is the Fourier series for the function f of x is a naught by 2 sigma n equal to 1 to infinity cos n pi x by L. But what is L value? Pi cancel. Bn sin n pi x by L. L value is pi cancel. So we get the Fourier series for the function f of x is a naught by 2 sigma n equal to 1 to infinity a n cos n x plus bn sin x. So now we have to find the a naught, a n, bn values. What is a naught value? 1 by pi integral 0 to 2 pi f of x into dx, and a n value 1 by pi integral 0 to 2 pi f of x into sin n pi x by L, pi cancel x. Next bn value 1 by pi integral 0 to 2 pi f of x into sin n pi x by L, pi cancel sin n x dx. Now we have to find the values of a naught, a n, bn values. What is a naught value? 1 by pi integral 0 to 2 pi f of x means e power minus x. What is e power minus x integration? Minus e power minus x, limits 0 to 2 pi. Substitute upper and lower limits. So what is upper one? We have taken minus common, minus 1 by pi. So if x is 2 pi, e power minus 2 pi minus lower limit e power 0. So this can be written as e power 0 1, e power 0. If we take minus common, e power 0 1, 1 minus e power minus 2 pi. Similarly, a n value. What is a n value? 1 by pi integral 0 to 2 pi e power minus x into f of x into cos n x dx. But what is f of x value? Cos n x. So it gives e 0 to 2 pi e power minus x into cos n x dx. So now we use formula e power ax into cos bx. What is e power ax into cos bx? E power ax by a square plus b square, a cos bx plus b sin bx. So now if you compare these two integrals, so what is a value? Minus 1, and what is b value? N. So applying this formula, we get e power minus x divided by minus 1 square is 1 plus n square, a cos bx, a is minus 1 minus cos n x plus b is n sin n x, limits 0 to 2 pi. Now substitute upper and lower limit. Upper limit is 2 pi, e power minus 2 pi by 1 plus n square minus cos 2 n pi plus n is 2 pi sin 2 n pi. So minus lower limit 0, e power 0 divided by 1 plus n square minus cos 0 plus n sin 0. So e power minus 2 pi by 1 plus n square, cos 2 n pi is 1 minus 1 plus sin 2 n pi is 0 plus 1 by 1 plus n square, cos 0 1 sin 0 0. So simplifying, we get 1 minus 2 pi divided by pi into 1 plus n square. Similarly, we have to find the bn value. What is bn value? 1 by pi integral 0 to 2 pi f of x into sin n x dx. But what is f of x value? E power minus x. So 1 by pi, so now apply formula. This is e power ax into sin bx dx. What is e power ax into sin bx dx? E power ax by a square plus b square, a sin bx minus b cos bx. So comparing these two integrals, a is minus 1 and b is n. E power minus x by minus 1 square plus n square, a sin bx minus sin n x, b cos bx minus n cos n x, limits 0 to 2 pi. So substitute upper limit 2 pi, e power minus 2 pi divided by 1 plus n square minus sin 2 n pi minus n into cos 2 n pi, minus lower limit 0, e power 0 divided by 1 square plus n square minus sin 0 minus n sin 0. We know sin 0 0, cos 0 1, sin 2 n pi is 0, cos 2 n pi is 1. Substituting all these values and simplifying, So we get 1 minus e power minus 2 pi into n divided by pi into 1 plus n square. Now substitute a naught, a n, b n values in equation 1. We get the required Fourier series. This is the required Fourier series after substituting the values of a naught, a n, b n values in the equation 1. Similarly, find the Fourier series expansion for the function f of x equal to x minus x square from minus pi to plus pi. So that means the given interval is minus pi to pi. C is minus pi, lower limit c plus 2l is pi, upper limit is pi. So what is c value? Minus pi plus 2 pi. Okay, so L2L is equal to pi, L equal to pi. So we know the Fourier series for f of x is suppose the given function is interval minus pi to pi, but we can verify whether it is even or odd. But x minus x square is neither even function nor odd function. Why? Because if you replace x by minus x, we are not getting the same function. Minus x minus x square. Minus x square is not a given function, so it is neither even function nor odd function. So we have to find all the values a naught, a n, b n values. So what is f of x? Fourier series is a naught by 2 n equal to 1 to infinity n cos n x plus b n sin n x. So find a naught, a n, b n values. A naught is 1 by pi minus pi to pi f of x dx. A n is 1 by pi minus pi to pi f of x into cos n x. B n is 1 by pi minus pi to pi f of x into sin n x. What is a naught value? 1 by pi minus pi to pi f of x. What is f of x value? X minus x square. Now integrate with respect to x. X value is integration x is x square by 2, x square integration x cube by 3. Upper limit is pi, lower limit is minus pi. Substitute upper and lower limits. Pi square minus pi cube by 3 minus lower limit x is minus pi square is pi square. Next minus plus lower limit is minus pi cube by 3. So simplifying we get minus 2 pi square by 3. So what is a naught, a n value? 1 by pi minus pi to pi f of x into cos n x dx. So what is f of x value? X minus x square. So minus pi to pi x minus x square into cos n x. So now we use UV rule. What is u v dx is u v1 minus u dash v2 plus u double dash v3. So u dash means the derivative of u and v1 means v1 integration of v. So choose u and v since x minus x square is algebraic function, cos n x is trigonometric function. Let us take u as x minus x square and v is cos n x dx using Euler formula. First inverse trigonometric, algebraic, logarithmic, trigonometric and exponential. So u is x minus x square, v1 integration of v cos n x. What is cos n x integration? Sin x by n minus u dash derivative of u x minus x square derivative x derivative 1 x square derivative 2x into v2. v2 means integration of v1. What is v1? Sin n x by n. Sin n x integration is minus cos n x by n. Already n is there in denominator, so minus cos n x by n square plus u double dash derivative of 1 minus 2x is minus 2 into v3 integration of v2. What is v2? This is minus cos n x by n square is v2. Integration of cos n x by n square is minus sin n x by n square into n. So that gives n cube. Now substitute upper and lower limit. We know sin n pi 0, sin of minus n pi 0, sin of minus n pi 0. So we can neglect these two terms which are having the sign terms, since sin n pi 0 minus sin n pi 0. So substitute x equal to pi. So we get pi minus pi square sin n pi 1 minus 2 pi cos n pi by n square 2 into sin n pi by n cube minus lower limit. Lower limit is minus pi. We know sin of minus pi is minus sin of minus pi is minus sin n pi. Cos of minus n pi is cos n pi. So simplifying, so we get 1 minus 2 pi into cos n pi. Cos n pi is minus 1 whole power n divided by n square. Next 1 plus 2 pi into cos n pi. What is cos n pi? Minus 1 whole power n divided by n square. So simplifying we get 4 into minus 1 whole power n by n square. Similarly bn value, what is bn? 1 by pi minus pi to pi f of x into sin n x dx. F of x is x minus x square. Again use same formula, UV rule. Sin n x minus x square is u and sin n x is v. X minus x square u into v1 integration of sin minus cos n x by n minus 1 minus 2x is the derivative of x minus 2x x minus x square, and v2 integration of v1 cos n x integration sin n x by n square plus u double dash derivative of 1 minus 2x is minus 2 and integration of sin is minus cos. So minus plus cos n x by n cube. Substitute upper and lower limits pi and minus pi. So upper limit pi, cos n pi is minus 1 whole power n, sin n pi 0, cos n pi is minus 1 whole power n. So substituting upper and lower limits we get minus 2 into minus 1 whole power n by n. So now substitute a naught, a n, b n values in equation 1, we get the required Fourier series. This is the Fourier series for the given function f of x equal to x minus x square in interval minus pi to pi. problem. Continue. Second problem, expand f of x equal to x sin x as a Fourier series in the interval 0, 2 pi. So given interval 0, 2 pi, so we have Fourier series in interval 0, 2 pi is a0 by 2 n equal to 1 to infinity a n cos n x plus b n sin x. So what is a0 value? 1 by pi 0 to 2 pi f of x dx, a n value 1 by pi 0 to 2 pi f of x into cos n x dx, bn value 1 by pi 0 to 2 pi f of x into sin x dx. Okay, comparing these intervals. So first you have to find a0 value. What is a0 value? 1 by L 1 by pi 1 by L c to c plus 2L f of x dx. But what is c value? 0, L is pi. So we get 1 by pi 0 to 2 pi f of x into dx. What is f of x value? X sin x. So now we use UV rule. X into sin x integration minus cos x minus x derivative 1 cos x integration sin x. So 0 to 2 pi, 2 pi x equal 2 pi minus 2 pi cos 2 pi minus minus plus sin 2 pi minus lower limit 0, 0 into cos 0, cos 0 0, sin 0 0, but cos 2 pi is 1 and sin 2 pi is 0, so which gives minus 2. Similarly, a n value, what is a n value? 1 by pi integral 0 to 2 pi f of x into cos n x dx. This is a n value. So now substitute x equal to f of x equal to x sin x. So now we have three functions. Okay, so now convert sin. Now use trigonometric formula. So sin a cos b, we have sin a cos b. What is sin a cos b? Half into sin of a plus b plus sin of a minus b. Using this formula, 2 sin a cos b, sin of a plus b plus sin of a minus b. Applying this formula, we get sin of x plus nx plus sin of x minus nx by 2. So now take u as x and v as sin of 1 plus n into x plus sin of 1 minus n into x. If we take x common, this becomes 1 plus n into x. This is 1 minus n into x. Now using UV rule, u into x into integration of v, sin of 1 plus n into x is cos of 1 plus n into x divided by 1 plus n into x derivative 1 plus n, and sin of 1 minus nx, 1 minus n into x integration minus cos of 1 minus n into x divided by 1 minus n. So minus u dash derivative of x is 1, again v2 means integration of v1, this is v1, cos of 1 plus n into x integration sin of 1 plus n into x divided by 1 plus n whole square, and sin of 1 minus n into x integration cos of 1 minus n into x integration sin of 1 minus nx divided by 1 minus n whole square. Now substitute upper and lower limits. Upper limit is 2 pi. So if you substitute upper limit 2 pi, sin of n plus x into 2 pi, that is sin 2 pi plus 2n pi, 0. If x is 2 pi, sin of n minus 1 into 2 pi, that is we can write 2 pi minus 2n pi. 2 pi minus 2n pi is also 0. Cos 2n pi is 1. So applying this formula, we have results here. Cos of 1 plus n into 0, 0. Sin of 1 plus n into 0 is 0. Sin of cos of 1 plus n into 2 pi is 1. Sin of n plus 1 into 2 pi is 0. Substituting all these values in the results, we get 1 by 2 pi. If we take 2 pi common, minus 1 by 1 plus n plus 1 by n minus 1. Take LCM, n plus 1 into n minus 1. So we get n square minus 1 by cross multiplication, minus n plus 1 minus plus n plus 1. So n minus n plus n becomes cancelled. So 2 by n square minus 1. This result is exists only if n is not equal to 1. If n is 1, so we get 1 minus 1 0, that is undefined. A n is not defined when n equal to 1. That's why you have to find a1 value. So put n equal to 1 in this result. So if n equal to 1, we get x into 2 sin x into cos x. So 2 sin x into cos x gives sin 2x, x into sin 2x. So use again UV rule, u is x and v is sin 2x. So u is x, v1 integration of v sin 2x minus cos 2x by 2 minus x derivative 1 cos integration sin. So minus sin 2x by 2 into 2, 4, limits 0 to 2 pi. Substitute upper and lower limit. Upper limit 2 pi sin 2n pi 0, lower limit 0. So minus 2 pi into cos 2n pi sin 2 into 2 4 pi 0 minus lower limit 0, 0 into cos 0 sin 0 0. So simplifying we get minus 1 by 2. That is a1 not value, a1 value. Similarly bn value, bn is 1 by l c to c plus 2 pi f of x into sin n pi x by l dx. 1 by pi 0 to 2 pi f of x into sin nx dx. So this is of the form 2 sin a sin b. So what is 2 sin a sin b? Cos of a minus b minus cos of a plus b. So that is cos of n minus 1 into x, cos of n plus 1 into x you can write. So now again use UV rule, u v1 minus u dash v2. Okay, x cos integration sin cos of n minus 1 x integration sin of n minus 1 into x divided by n minus 1, cos of n plus 1 into x integration sin of 1 plus 1 into x divided by n plus 1. Again x derivative 1, again this is v2 integration of the sin integration minus cos. Now substitute upper and lower limits. Upper limit 2 pi, lower limit 0. We know sin of n minus 1 into 2 pi 0, sin of n plus 1 into 2 pi 0, cos of n minus 1 into 2 pi is 1, cos of n plus 1 into 2 pi is also 1. So simplifying we get bn value 0. So this is possible only when if n is not equal to 1. So in this result if n is 1, 1 minus 1 0, this is undefined. So now again we have to find b1 value. Substitute n equal to 1 in this bn result. This is bn 1 by pi x into or we can write 1 by 2 pi 0 to 2 pi x into 2 sin x into sin x. So if n is 1, 1 by 2 pi 0 to 2 pi x into 2 sin x into sin x, that gives 2 sin square x. So what is 2 sin square x? Sin square x only, right? 2 to cancel. Okay, sin square x can be written as 1 minus cos 2x by 2. So 1 by 2 taken out of integral x into 1 minus cos 2x. So now again use UV rule. So u is x and v is 1 minus cos 2x. X into x1 integration is x, cos 2x integration is sin 2x by 2 minus derivative of x is 1, x integration x square by 2 minus sin 2x integration minus cos 2x by 2, 2 into 2 4. Substitute upper limit lower limit 0 to 2 pi. So 2 pi minus sin 4 pi minus x square 2 pi square 4 pi square minus cos 4 pi by 2. Lower limit 0, if x is 0 0, if x is 0 0, cos 0 1. So this is minus 1 by 4. Simplifying sin 4 pi 0, cos 4 pi 1. So we get bn value pi. Now substitute a0 a1 an b1 bn values. Sigma n equal to 1 to infinity a0 by 2, sigma n equal to 1 to infinity becomes a1 cos x plus b1 sin x, a1 cos x plus b1 sin x plus sigma n equal to 2 to infinity you can write sigma n equal to 2 to infinity an cos x plus bn sin x. So now we substitute a0 an bn values, we get the required Fourier series. Yes. So next question, expand f of x equal to square root of 1 minus cos x in the interval 0 to 2 pi as a Fourier series. Hence evaluate 1 by 1 into 3 plus 1 divided by 3 into 4 5 plus 1 divided by 5 into 7 and so on. So f of x equal to square root of 1 minus cos x. 1 minus cos x is 2 sin square x by 2. So square root cancel, square root of 2 into x by 2. Given interval 0 to 2 pi. So f of x is a0 by 2, n equal to 1 to infinity an cos x plus bn sin x. What is a0 value? 1 by pi integral 0 to 2 pi f of x into dx. So 1 by pi f of x, and what is f of x value? Root 2 into sin x by 2. So sin x by 2 integration minus cos x by 2, again x by 2 derivative 1 by 2. Substitute upper and lower, upper limit 2 pi minus lower limit 0. 2 to cancel, cos pi is minus 1, lower limit is 1, minus 1, minus 1 minus 1 minus 2, minus 2 into minus 2 minus plus 4 root 2 divided by pi. Similarly an value 1 by pi 0 to 2 pi f of x into cos nx dx. F of x is root 2 into sin x by 2 into cos nx dx. Now we use 2 cos a sin b formula. What is 2 cos a sin b? Sin of a plus b minus sin of a minus b, where a is nx and b is x by 2. So nx plus x by 2, n plus 1 by 2 into x minus sin of n minus 1 by 2 into x. Again integrate using so again integrate with respect to x. Sin x integration minus cos n plus 1 by 2 x divided by n plus 1 by 2 x derivative n plus 1 by 2. Sine integration minus cos minus minus plus cos of n minus 1 by 2 into x divided by n minus 1 by 2. Now substitute upper and lower limit. Upper limit is 2 pi and lower limit is 0. If you substitute upper limit 2 pi, x equal to 2 pi, take LCM 2n plus 1, 2n plus 1 by 2 into 2 pi. Similarly, this is 2n minus 1 by 2 into 2 pi. So minus 2 by 2n plus 1. So 2 to cancel. This 2 to cancel. How it is possible? Okay. 2 to cancel. 2n plus 1. 2n plus 1 into pi. What is 2n into plus 1 into pi? It is minus 1. So cos of 2n minus 1 into pi is minus 1. Substitute these two values here and simplify. Take LCM and simplify. So get minus 4 root 2 pi into 4n square minus 1. Similarly, Bn value. Bn is 1 by pi integral 0 to 2 pi f of x into sin n x dx. 1 by pi 0 to 2 pi f of x is root 2 into sin x by 2 into sin n x dx. Now we use formula 2 sin a sin b. What is 2 sin a sin b? Cos of a minus b minus cos of a plus b. Cos of n minus 1 by 2 x minus cos of n plus 1 by 2 into x. Integrate with respect to x. Cos integration sin. Sin of n minus 1 by 2 into x minus n minus 1 by 2. Cos integration sin. Sin of n plus 1 by 2 into x divided by n plus 1 by 2. Substitute upper limit 2 pi, lower limit 0. So I think Bn value becomes 0. Why? Because sin of 2n minus 1 into 2 pi, sin of 2n plus 1 into 2 pi gives sin 2n pi. Sin 2n pi is 0, sin 0 0. So the limit values, upper and lower limit values becomes 0. Now substitute a0 an Bn values in equation 1. So we get the required Fourier series. Okay, result. So we have to deduce the result. So for deduction, put x equal to 0 in this Fourier series. If x is 0, cos 0 1, 1 minus 1 0, 2 root pi 4 root 2 by pi, cos 0 1, cos 0 1, cos 0 1. So we get 0 equal to 2 root 2 by pi minus 4 root 2 pi, 1 by 3, 1 by 15, 1 by 35. So this can be written by cross multiplication. You can write 3 can be written as 1 into 3, 15 can be written as 3 into 5, 35 can be written as 5 into 7. By cross multiplication, we get this is 2 root 2 pi by this. By cross multiplication, pi cancel, so it gives 1 by 2. Control enda ఇండిలో కొంచెం ఒక 5 నిమిషాలు ఇది ఒక ప్రాబ్లం అసలు రికార్డ్ అవుతుందో లేదో ఫస్ట్